Okay, so we all would have done linear programming problems, LPP as we call them, in school or in college. Like some of us would have it in college, but many of us wouldn't. But what I noticed is that we always do it like on our own. We don't or calculators, which kind of becomes cumbersome. So I thought for assignments, anything for that matter, it'll be easier if we learn how to leverage Excel. So yeah, so I've taken a simple LPP which has been mathematically formulated. Um, so yeah, we have to minimize this objective functions. We have to find such x and y such that z is minimum and z is equal to 16x plus 16y. And it has these two constraints. It should also, x and y should also be such that these two constraints are true. And x comma y is greater than or equal to 0. That is x and y are non-negative. So we have to find values of x and y. So let's write down that first. Values of x and y. And then the objective function should be minimum. Minimum, right? So 16 times x plus 16 times y. We're just entering the coefficients. So that will be minimum z. We have to find minimum z. Minimum z is equal to this times x plus this times y, right? Or we could simply just write it as sum product. Sum product is just summing the products. That is, the two arrays, say a1, a2 and b1, b2. a1 into b1 plus a2 into b2 will be given by sum products. So it is summing two products, that is 16 times x and 16 times y. So 16x plus 16y. So one array times the other. Now we add the constraints. First constraint is 2 times x plus 4 times y. And the value we get, whatever value we get, should be greater than or equal to 3, right? It's 3 here. Similarly, the second constraint is 3 times x plus 2 times y, and whatever value we get should be greater than or equal to 4. This 4 here, right? So then 4, sorry, we'll just put it here. And then this will give us some product of, it's the same as what we did for the objective functions, 2 times x plus 4 times y. So array 1 is the coefficients of the first constraint into the unknown variables. So same thing for the second constraint, the coefficients of constraint 2 comma unknown variables. Okay, so now we use the solver option in data. So we go to data, solver. We have to maximize this, right? Now we have to change the values of x and y such that it is minimum. This is minimum. So we'll just delete the old constraints. We're adding. So this has to be greater than or equal to 3, right? Or we can just change it. Instead of 3, we can just add this. Okay. Similarly, we add another one. This for the second constraint has to be greater than or equal to this, right? This has to be greater than or equal to 4. So okay. And in options, we haven't talked about non-negativity constraint. We check Here it's non-negative. We are assuming that it's non-negative because in real life scenarios we find the number of things which cannot be negative. So we mostly assume non-negative, but in many cases, it also happens that we do accept negative values. So we are assuming that it's not negative because that's what the constraints ask us to do. So, okay. So now we solve it, and we have found a solution. So it's as simple as that. It takes like 5 or 6 minutes to do it, and yeah, that's about it. So it's much easier than uh, anything else, like actually doing it. So yeah, thank you.